Hello, everybody. My name is Laurent, and yeah, we thought it'd be fun for me to go through some of my favorite things in Maple. I've been a Maple user for the past 30 odd years, and we'll go through some things in Maple that I think are nice, are cool, and hopefully there'll be a few things for everybody that maybe are new or surprising. So we'll find out. So with that, let's start with something really simple. So something like do the sine of pi over 3. So something very simple, but illustrates actually two of my favorite things in Maple. One is that you can get exact answers. So as opposed to just getting a number, you get an exact symbolic result that typically gives you a lot more insight into an answer. And at the same time, when I did this, I used a mathematical notation. So as opposed to having to enter this using some kind of a syntax, I entered it the way I would, pretty much the way I would write on paper. And also that's the way it appears. So I don't have to count brackets or anything to figure out what this means. It's just there. It's easy to see, easy to understand. Okay, so we got an exact answer here, but of course we can go and we can approximate that. So here to 50 digits. So and that's maybe the next thing about Maple that I really like is that it's very easy. So we did all these things with just a few keystrokes, a few clicks. We got an answer. It's really easy, right? There's not all that much you have to know to take your first steps and to get your first results. This is important because not everybody has time to first learn a whole system, learn a language, right? You want to get going. You want to get things back from a system like Maple quickly, easily, without there being a huge learning curve. But it also brings me to the next thing I really like about Maple is that all that UI, those niceties, the ease of use, doesn't get in the way of you taking advantage of all the power that's behind this. So here's an example. I again, right, this is looks easy. There's no complexity there, but I can have a look at what's going on under the hood. I can go and show the command for this. So then now Maple exposes what's going on behind this document, and is actually showing us what command is being used to evaluate this result numerically. So that's also a good way to learn the language that's behind this over time. And I can go and I can modify this, right, and update the result. All right, then we can, I can leave this. And then maybe while we're talking about approximations and exact results, there's another really nice feature like about Maple that's maybe a bit surprising and almost looks like magic. And that's the identify command. So identify, you can give it just a few digits or a floating point number, and it will try to give you back the most probable exact expression under some metric. So here it's able, if I just give it the first 4 decimals of this big number here, it is able to reconstruct that this actually is square root of 3 over 2. Which again is useful because it's something like this fraction is gives you a lot more insight into what the result actually means than a big floating point result. All right, the other thing maybe to notice here is that when I typed in this expression, I typed in pi and I got the pi symbol here. And generally, there's Maple allows you to use a lot of different mathematical symbols within your documents. Right? But But one nicety here is, one nicety here is, if you don't know what the name of the symbol is, so I can say alpha, right? And I can hit escape and it turns into the alpha. But if I don't know what it is, I can also go and use the handwriting part. And I can sketch my my symbol and just drag it into the document. Right? So Maple has thousands of these mathematical symbols that you can use to annotate your documents, to right, make it look like a page in a textbook. And if you need to find the symbol real quick, well, this is a good way to just look it up. You sketch it. It doesn't have to be pretty. I will find it. You can enter it into your document. All right. Let's get on with the next set of examples. Let's enter a polynomial, x squared minus 1. Again, we'll do this simple. But the next real nice feature of Maple is that on the right here, you have the context panel. And the context panel gives you a selection from the over 5,000 different commands that Maple has. Gives you a selection of just the ones that are probably the most applicable on exactly the math that you typed in here. So I entered this polynomial, and I get options like I can differentiate this, right? I get the derivative, or maybe I want to solve it. I get the solutions, the roots. So again, really easy to do. You don't have to remember the command name. It's all there at a click. If you want to know what's going on behind the scenes here, we showed you before how to do that, right? So you can always go and see what's going on. But this is a really easy way to get at the power of Maple, again, without having to learn the whole language and know the ins and outs of the system ahead of time. Really nice here too is that in addition to these commands, you also get a small selection at the top that gives you a preview of what the result might be. So here, for example, it has the factor command, but at the same time, it tells you, okay, there's actually factors, and this is what it will look like when I select it. So I get a preview. I don't have to do this blind. I know ahead of time that this polynomial actually has two factors, and I can get them by clicking on this. Same with the plot. I get a preview of what the plot will look like. I click on it, it inserts in a document, right? But again, I get the preview first. I get a sense of what I can do and what I will get. All right, and this is a univariate polynomial. We can do similar things with a multivariate polynomial here, x squared minus y squared. Again, we get the preview. We get the preview of the 3D plot. I can insert this 3D plot into my my document, and we'll make it transparent. We can change the style. Can rotate this thing. There's a bit of a challenge over Zoom, but it seems to work. All right. So definitely one of my favorite things in Maple is the ability to do plots. And we've seen 2D plot, we've seen 3D plot. Maple has a lot of different built-in plot types, all sorts of kinds that you can start from to illustrate various aspects of mathematics and science. And again, plots are obviously a really good way to get insight into the math that's behind the problem. I've just browsed through this just to give you a sense of just the breadth of things you can do here, right? Definitely plots are right up there on top of my list of favorite features in Maple. Now this just keeps going and going. All right. Let's see. All right. Next, let's change gears a little bit. So I'll start with the expression palette here. Let's enter a sum. I'll enter the sum from I from 1 to n of I. And I can evaluate this. We get a formula in terms of n, right? So the sum of the n first integers is a formula in terms of n. I can factor this, right? You get maybe the more familiar form of this formula. But another way to do this is I can go back and I'll wrap the factor command right around this, and we get that same formula. And now I can go back and I can Maple is about exploring, and Maple is about looking behind the scenes of what's going on in math, right? And trying out things. So I can see what happens if I change this I to an I square, and I get a different formula. I can go and make it a cube, get this formula. But also I can make that exponent here a parameter. So I'll now make that a parameter, and I'll say, okay, let's okay, I'll get rid of this thing, and now, so I have a similar sum, but now my exponent is a parameter. So what can I do with this? I can't evaluate it because the result depends on what k is, right? But what I can do is I can click the explore button here, and that allows me to pick a variable. So k, I want to explore k, and that creates a UI for me essentially, where k is now a parameter, and as I drag the slider, it shows me what the result is for that particular value of k. And so the explore command, definitely one of my top favorite features of Maple, because it's easy. You go from a mathematical expression to a UI that you can use to explore mathematics, to explore a problem, to get some insight into what's going on. And okay, so I have this Maple document here, and I can maybe consume that in different ways. So one way, of course, you can save this and you can send it to somebody. You can use the slideshow mode. So I can turn on the slideshow mode. It essentially takes my current Maple document and displays it full screen. Every section is a slide, and you can move between slides. I only have one slide, but the nice thing is that it's still active. So I can still, in full screen mode, in slideshow mode, I can still change the parameter and still demonstrate what's happened. Okay, other ways to consume this. Let's get rid of this thing maybe. Give it a title. Make it a bit prettier. And then I can go and I can say, okay, I want to save this to the cloud. I give it a title. I'll call it summation. And I'll save it to the cloud. Did this beforehand, so I won't do it again. But I can then go to the Maple cloud, into my private group here. It shows up as a link. I click on the link. Now that same document that we just played with in Maple shows up in my browser, and it's still live, and I can still change the slider and see what's happening. But of course, this now is independent of my desktop computer, independent of my copy of Maple. I can share this document with anybody, whether they have Maple or not, and they'll be able to use it. All right. So this was an example of building an app in Maple that has interactive elements. But it doesn't stop there. I mean, Maple comes with a selection of the pretty big selection of built-in apps that are in a similar way using interactive elements to build a UI on top of a mathematical concept, with the goal of illustrating that concept and making the math come alive. So there's tons of these in Maple. I'll show just a few. Let's maybe start with discrete mathematics. See, the Euler Identity is a nice one, for example. So this starts with a bit of a mathematical description of what Euler's formula is and where it's coming from, and then it tells you one fact that one way to define the Euler formula is by having it be the limit of this expression when n goes to infinity. And then using that definition, we can build a visualization of this. So here we have the parameter n here. We put that on the slider, and then we can see what happens if I increase the value of n. Right? We approximate -1 as the right-hand side of the Euler formula. Play this. So it's just an example, right? But it's an example that of one of many that illustrates how you can make a mathematical concept come alive using clever visualizations and also interactive element that allows somebody to actually get their hands on it, right, and manipulate it directly and see what happens, because that's when understanding happens, when you can interact with something and you can see what's going on. Let's see if I can go back here. Let's look at a few more. Let's look at, we can maybe look through this collection as kind of a nice one, because this also illustrates that math matters in so many domains, right? So this is a collection from the natural sciences, and really makes the point that you find math everywhere. And in so many domains, from biology to chemistry to physics, you find math, and these math apps help you illustrate certain concepts and help you again make them come alive, help you further understanding. And then maybe one more. We'll go to the functions one, and there's a nice one on Bezier curves. And again, this starts with an explanation of some of the mathematics behind Bezier curves, but then has an interactive element that shows you Bezier curve, and now you can actually manipulate these control points directly. You can move the control points of the Bezier and see what that does. Right? So it takes a pretty abstract concept and turns it into a hands-on activity that you can use to really get a feel of what do these control points mean, and what do they do to the curve. All right. And which brings me to the next really cool thing about Maple is that all of these math apps that you've seen, there's no magic there. They've all been built using tools that are available to any Maple user. And let me show that just by maybe constructing one of those, a simple one, but let's construct one on the fly, right? So we go to the palettes here, we go to the components palette, we bring in a plot component to start, and we want to make it interactive, so we're also gonna get a slider. On the right here, you have some information on these components. And then, okay, let's make this update continuously. And then I want to change the code for it. So here is all you have to do is whenever somebody changes the slider value, some Maple code will get executed. And we can write this Maple code. We'll do something simple. We'll say that we will plot the sine of the slider value times x over 10. We'll plot this from minus pi to pi. All right, so we run this plot command based on the value of the slider, and then the result of plot command we put into plot 0, which is the name of our plot component. So that's really all it takes. We can run this up in the parentheses here. I'll probably have one too many there. Okay, let's try it again. The plot shows up. I can move the slider and it updates as I move it. Right? So just a few seconds here, we built a very simple interactive math app. But building the more complicated ones that I showed you earlier is really no different, right? You can add pictures to it, you can add more controls, you can add more different formulas, you can add more code, you can add buttons. Right, but the principle is the same. It's in the end pretty easy to construct, and there's a lot of power there that you can take advantage of to build just the math app that you need or want. Which is a nice tie-in to my next thing in my top things that I like about Maple is that. Maple has a pretty powerful language that's going on behind the scenes here all the time, and that language is of course accessible to any user. There's no barriers there, and it goes in so far that whenever you do sophisticated math with Maple, right? Let's say I want to calculate an integral. Let's say x minus 1 over x cubed minus 1. And not a trivial integral. I get a result. This is probably not super easy to do by hand. But whenever you have Maple do advanced mathematics, the code for doing that is very likely Maple code, the same language that any Maple user has access to build their own programs, their own algorithms inside of Maple. So 90% of Maple's mathematical algorithms are implemented using Maple's own language. This makes it a really easy to extend system. You can add your own functions to it. You can change the behavior of it. all the code or most of the code in Maple is you can look at it. You can look at what the code is behind commands like integration in Maple. So it's a very open system that way, which is definitely on top of my list as well. All right, so getting to the end of the time here. I mean, I'm not sure whether we got to 20 yet, but what we can always have a part 2 of this. I have 2 more that I want to talk about. One is so if we go here. So the Maple calculator is it's kind of a relatively new thing for us. So there is a mobile app called the Maple calculator that you can get for iPhones and Android. And it has a lot of Maple's power right on your phone. Not all of it, but there's a lot there. And it's definitely a handy thing to be able to have access to at least some of Maple on your phone. So if you haven't already, please check it out. I think that's it's a very cool companion to Maple. And then the final one, I mean, probably the number one favorite thing about Maple is its user community. So people like you out there, people that use Maple every day, that build Maple applications, share it with colleagues, share it with students. A very vibrant and active community that is always there to help each other. So thank you, because the Maple community is definitely a big piece of what makes Maple unique, and a big piece of why I'm so excited about Maple even after those 30 years.